Okay, my name is Helen Gardner, and I'm going to be talking a little bit about penicillin. So, penicillin is an antibiotic. It's a group of antibacterial drugs that attack a wide range of bacteria. Experts credit Alexander Fleming with the discovery of penicillins, and penicillins work by interfering with bacterial cell walls. Some types of bacterial infections that may be treated with penicillin include pneumonia, strep throat, meningitis, syphilis, and gonorrhea. This is a little bit about how they function. Drugs in the penicillin class work by indirectly bursting bacterial cell walls. They do this by acting directly on peptidoglycans, and peptidoglycans create a mesh-like structure around the plasma membrane of bacterial cells, which increases the strength of the cell walls and prevents external fluids and particles from entering the cell. And when bacterium multiplies, small holes open up in its cell wall as like the cells dividing, and newly produced peptidoglycans then fill the holes to reconstruct the walls. And penicillin blocks the protein struts that link the peptidoglycans together. This prevents the bacterium from closing the holes in its cell walls. And as the water concentration of surrounding fluid is higher than that inside the bacterium, water rushes through the holes in the cell and the bacterium will burst. And then, like other drugs, penicillin can undergo antibiotic resistance. Through mutation and selection, bacteria can develop defense mechanisms against antibiotics. Resistance happens when bacteria come in contact with antibiotics and survive. And mutations in their genes allow some bacteria to survive these antibiotics, and they pass these genes along to their descendants. This is how antibiotic resistant strains of bacteria are formed. And for example, some bacteria have developed biochemical pumps that can remove an antibiotic before it reaches its target, while others have evolved to produce enzymes to inactivate the antibiotic. Inhibiting an enzyme like transpeptidase that catalyzes the last step in bacterial cell wall biosynthesis. The defective walls cause bacterial cells to burst. Some bacteria can subtly change the format of the penicillin binding proteins in their peptidoglycan wall so that penicillins can no longer bind to it. And then some side effects of penicillin. More common side effects are diarrhea, nausea, headaches, skin rashes, and hives. And then less common side effects are shortness of breath or irregular breathing, joint pain, puffiness and redness of the face, scaly red skin, sore mouth and tongue, sometimes with like white patches, and abdominal cramps. And then I included the chemical structure of penicillin. This is what it looks like. And then here I included a 3D chimera structure of penicillin, the binding protein. And then here are some of the references I used